An emblem as shown in figure 1 consists of a triangle ABC joined to a sector CBD of a circle of radius 4 and centre B. The points A, B and D lie on a straight line with AB equal to 5 centimetres and BD equal to 4 centimetres. Angle BAC is 0.6 radians and AC is the longest side of the triangle. We need to show that angle ABC is 1.76 radians. So let's just focus on that triangle here. And note that we have a matching pair. We've got the 0.6 radians that is opposite the 4 centimetres. So therefore we can use the sine rule for this. We can say that sine 0.6 radians divided by 4 is going to be equal, now the other side we have is 5, and that's opposite the angle C. So we could say that that's going to be equal to sine C over 5. Multiply both sides by 5. And then do sine inverse of both sides to work out angle C. Now, using your calculator, because we are in radians, you need to make sure that your calculator is in radians mode. So make sure that you've got a little R written at the top of your calculator display. If not, you need to change the mode. If you type that into your calculator, you should find out that C is 0.7835 radians. So that's the angle C here. Therefore, to work out the angle that we want, this angle here, angle ABC, we know that the angles inside a triangle add up to pi radians. Angles in a triangle add up to pi radians. We know in degrees that the angles add up to 180. In radians, 180 is pi radians. So the angles in a triangle add up to pi. So if I now do pi, take away the 0.6 radians, take away the 0.7835 radians, I get 1.76 radians to 3 significant figures. Excuse me. So that's part A. Part B says work out the area of the emblem. So the total area. So let's first work out the area of the triangle. We've just worked out that this angle here is 1.76. So the area of the triangle, we can use the formula half AB sine C, where C is the angle in between the two sides, the A and B. So notice that our 1.76 is in between the 5 and the 4. So half times 5 times 4 times sine 1.76, making sure that your calculator, like I say, is in radians. And we get 9.82. So that's the area of the triangle. Now, to do the area of the sector, so area of sector, the formula for that is a half r squared theta, where theta has to be in radians for that formula to work. Now we can see that obviously r is 4. We'd like to know what the angle theta is here. Well, notice that we have a straight line here. And we know that the straight line, the angles on a straight line, will add up to pi radians. So if I do pi minus the 1.76, then I find that this angle here is 1.38. So now I can work out the area of the sector as a half times 4 squared times 1.38. And I get 11.05. So the total area, add those two results together, and we get 20.9 centimetres squared.